So how about to get the equation of a straight line given 2 points, let's try -1, 5, and 4, -10. Let's try those 2 points. And our first step always is going to be to find the gradient. So if we want to find the equation of a straight line, we need to find the gradient of that line. And you go, okay, what's the gradient? It's the rise over run, which means the change in y over the change in x. And at this point, if you want to label x1, y1, and x2, y2, you can. We can label them up there, and then we say, okay, that's -10 minus 5. There's a change in y over the change in x. That's 4 minus a -1. -10 minus 5 gives me -15. 4 minus -1 is 5, and so my gradient is -3. Second step is we're going to use point gradient formula. Point gradient formula, which is this. And what the point gradient formula is it's just that, it's when you substitute one point, meaning one of these points, into the formula, and the gradient, which is m, which we already figured out. Okay? So all you need for point gradient formula is literally one point and the gradient. Okay? So now that we have this, what we're going to do is substitute m and 1 point, x1, y1, into the formula. And now I'm going to move up here and see how that looks. So let's check this out. So that means let's see, y1 is 5. Y minus 5 equals my gradient, which is -3, brackets x minus x1 minus -1. So there's x1. There's y1. And I'm going to clean that up a bit, because minus -1 is just +1. Okay, that looks a little bit better. Okay, so I mean this is fine. You've written the equation, but we're not used to writing it like this, and we're used to writing it kind of in gradient intercept form. So if I want to do that, all I have to do to get it from this form into y equals mx plus c is I'm going to expand right there.
It's frozen.
Sorry about that. There we go. I'm going to expand right there, so I get y minus 5 equals -3x minus 3. And then what I'm going to do is that -5 is going to switch to the other side and become +5. So y equals -3x, then at -3 plus 5 gives me y equals -3x plus 2. So those 3 steps again: find the gradient, substitute that gradient and any other point into that formula. It actually doesn't have to be x1, y1. You could have put x2, y2 in there. So you get an equation that looks like this. And if you want to clean this equation up, you expand, shift that constant term to the other side, changing its sign, and then you have it in a nice gradient intercept form ready to go. You can try some more examples. Okay, for the first example, I got negative 8/3 for my gradient, and it's a fraction, but that's okay. Don't decimalize that, because it'll give you a recurring decimal, 0.3 repeating, so we don't want to do that. Now I'll substitute it into the equation y minus y1 equals mx minus x1. Pick either point, it doesn't really matter which point you pick. Y minus 3 equals negative 8/3 x, and since minus a negative 2 is just plus 2, I'm just going to write it like that. So now expand, and it's a fraction, but it's okay. We don't panic just yet. When I expand it to that, I get negative 8/3 x, and when I expand it to that, I get minus 16/3. And we can do that on the calculator, and we want to avoid double signs like plus a negative 16/3. And my last step is going to be to take that positive 3 and shift it to the other side and add it. So negative 8/3 x minus 16/3 plus that 3. And that gives me negative 8/3 x. So when I do combine these, I get a negative 7/3. And they're fractions, but life's not perfect, so we're not always going to get nice whole numbers. Whoa. Hey. Yeah, of course. So in this example, we find the gradient. Change in y, 1 minus 1 over 7 minus negative 3. That gives me 0 over 10. That gives me 0. It's a horizontal line, of course. So that means y minus 1 equals 0, x plus 3. Remember, minus a negative 3 is plus 3. So when I expand all that 0, 0 times anything is 0. Shift that negative 1 over to the other side, and I just get y equals 1, which would just look like a horizontal line going through 1 on the y-axis. Right there. So what do you think? That's it for now. That is it for now on those notes.